Solid-state drive SSD by Hiten D22DCS174. Index: Development and history. Early SSD using RAM and similar technology. Flash-based SSDs, enterprise flash drives, architecture and function, controller, memory, flash memory-based, DRAM-based, other. Cache or buffer, battery or supercapacitor, host interface. Form factors, comparison with memory cards and applications. Introduction. A solid-state drive (SSD) is a data storage device. Integrated circuit assemblies has memory to store data effectively. SSD technology uses electronic interfaces compatible with traditional block input-output hard disk drives, thus permitting simple replacement in common applications. SSDs have no moving mechanical components. Compared with electromechanical disks, SSDs are typically more resistant to physical shock, run more quietly, have lower access time, and less latencies. Advantages over hard disk drive: reliability in portable environments and no noise, no moving parts. Faster startup does not need any spin. Minimal heat production, minimal power consumption, lightweight, ideal for laptops. Deterministic read performance. The performance does not depend on the location of the data. Disadvantages: cost significantly more per unit capacity, limited write erase time, slower write speeds because of the erase blocks are becoming larger and larger, 1.5 ms per erase. For low capacity flash SSDs, low power consumptions and heat productions when in active use. High capacity SSDs may have significant high power requirements. Performance can drop as the disk get filled. Firmwares and controller are complex. Development and history. Early SSD using RAM and similar technology. SSDs had origins in the 1950s with two similar technologies: magnetic core memory and card capacitor read-only store, basically called as CC-ROS. Later in the 1970s and 1980s, SSDs were implemented in semiconductor memory for early supercomputers of IBM, Amdahl, and Cray. Software-based RAM disks are used as of 2009 because they are an order of magnitude faster than fastest SSD, though they consume CPU resources and cost much more on a per GB basis. Flash-based SSDs. In 1994, STAC bought Cirrus Logic's flash drive controller operation, allowing the company to enter the flash memory business for consumer electronic devices. In 1995, M Systems introduced flash-based solid-state drives. They had the advantages of not requiring batteries to maintain the data in the memory but were not that fast. Enterprise-based flash drives. Enterprise flash drives (EFDs) are designed for application requiring high input-output performance, reliability, energy efficiency, and more recently consistent performance. In most cases, an EFD is an SSD with a higher set of specifications compared with SSDs that would typically be used in notebook computers. Architecture and function. The key component of an SSD are the controller and the memory to store the data. Other components play a less significant role in the operation of SSD and vary among manufacturers. Controller. The controller is an embedded processor that executes firmware level code and is one of the most important factors of SSD performance. Every SSD includes a controller that incorporates the electronics that bridge the NAND memory components to the host computer. Some of the functions performed by the controller include error correction, wear leveling, bad block mapping, read and write caching, garbage collections, and encryptions. Memory. There are three types of memory: in SSDs, flash memory based SSDs, DRAM based and other. First of all, flash memory based SSDs. SSD manufacturers use non-volatile NAND flash memory in the construction of SSDs because of the lower cost compared with the DRAM and the ability to retain the data without a constant power supply, ensuring data persistence through sudden power outages. Flash memory SSDs are slower than the DRAM solutions. Lower priced drives usually multi-level cell flash memory, which is slower and less reliable than single-level cell flash memory. DRAM based. SSDs based on the volatile memory such as DRAM are characterized by ultra-fast data access, generally less than 10 microseconds, and are used primarily to accelerate applications. DRAM-based SSDs usually incorporate either an internal battery or an external AC/DC adapter and backup storage systems to ensure the data persistency while no power is being supplied to the drive from the external sources. If power is lost, the battery provides power while all information is copied from random memory to backup storage. When the power is restored, the information is copied to the RAM from the backup storage and the SSD resumes normal operation. While the price of DRAM continues to fall, the price of flash memory falls even faster. Other Some SSDs use MRAM, magneto-resistive random access memory. Some SSDs use both DRAM and flash memory. When the power goes down, the SSD copies all the data from its DRAM to flash. When the power comes back up, the SSD copies all the data from its flash to DRAM. Some drives use a hybrid spinning disk to flash a memory. Cache or buffer. A flash-based SSD typically uses a small amount of DRAM as a cache, similar to the cache in hard disk drive, battery or superconductor. Another component in high-performing SSDs is a capacitor, some form of battery. These are necessary to maintain data integrity such that the data in the cache can be flushed to the drive when the power is dropped. Some may even hold power long enough to maintain data in the cache until power is resumed. Host interface. The host interface is not specifically a component of the SSD, but it is a key part of the drive. The interface usually incorporated to the controller. Form factors. The size and shape of any device is largely driven by the size and shape of the components used to make that device. If an SSD is made up of various interconnected ICs and an interface connector, then its shape could be virtually anything imaginable because it is no longer limited to the shape of rotating media drives. The various forms include standard HDD form factors, standard card form factors, box form factors, bare board form factors, ball grid array form factors. Comparison with memory cards. While both memory cards and most SSDs use flash memory, they serve very different market and purposes. Each has a number of different attributes which are optimized and adjusted to best meet the needs of particular users. SSDs were originally designed for use in computer systems. In contrast, memory were originally designed for digital cameras and later found their way into cell phones, gaming devices, GPS units, etc. Most memory cards are physically smaller than SSDs and designed to be inserted and removed repeatedly. Applications. Until 2009, SSDs were mainly used in those aspects of mission critically applications where the speed of the storage system needed to be as fast as possible. SSDs are used in telecommunications corporations, streaming media, and video editing firms, etc. Also, laptops have now SSD hybrid drives which consist of SSDs. SSDs based on SD card with a live SD operating system are easily write log, combined with a cloud computing environment or other writable medium to maintain persistence. An OS booted from a write log SD card is robust, rugged, reliable, and impervious to permanent corruption. 2000, in 2011, Intel introduced a coaching mechanism for their Z68 chipset and mobile derivatives called Smart Response Technology, which allows a SATA SSD to as a cache configurable as a write to and a write back for a conventional magnetic hard disk drive. That's all. Thank you.